So I want to talk about this project, which I'm doing jointly with Vic Leifers, Mike Flanagan, and Nadir Ugbin from the department, and collaborating with Derek Sitters and Tim Kitty from CFS, and you'll hear about Derek's project afterwards. Let's see. So the objective of this project is really to start looking at understanding the successional development of stands post mountain pine beetle and how we can facilitate regeneration in these stands. So our objectives of the project, first of all, are to look at the potential for natural regeneration of lodgepole pine post-MPB attack for different types of ecosites in west central Alberta. And then our original objective was to assess the health of residual lodgepole pine and regenerating seedlings in these stands. Then third, to develop tools for actively managing these stands to rehabilitate them and encourage regeneration. And then the fourth piece of that is to look at the fire risk piece, which is Mike Flanagan's piece. So looking at what the fire risk is associated with treating these stands, doing this kind of new silviculture and harvesting in these stands post mountain pine beetle. So those were our original objectives. You'll see they switched a little bit. So I'm going to talk about the first year of the project, which was last summer, where we undertook an effort to survey sites throughout west central Alberta to look at the extent of natural regeneration of lodgepole pine in stands that had been attacked by mountain pine beetle. And our initial criteria for stands were that the stands should be 70% pine stands. They should be at least 50% gray attack. We had first had 70% gray attack, and we weren't finding a lot of stands that met that, so we dropped it to 50% gray attack. Less than 400 trees per hectare advanced regen, so we weren't interested in stands that had a substantial amount of advanced regen. We were interested in the stands that basically were relying on pine or didn't have anything else to replace the canopy of pine once it was dead. Not treated at all, longest time period possible post mountain pine beetle, and for a range of ecosite types. So we looked at PSPs, vegetation inventory data, high resolution images thanks to AESRD, GIS work, did a lot of work on trying to find sites that we should be searching at, and then the crews went out and visited these sites on the ground and said, did they meet our criteria? And if they met our criteria, then they undertook a full sampling protocol to quantify the forest structure and look at the mortality of the existing canopy and to search for seedlings. And we went mostly in west central Alberta, and then we wandered into BC a little bit when we started to get really desperate, when the crews got too depressed for looking for seedlings and not finding any. So here you can see the areas that we surveyed. The red dots are the full protocol sites, which ended up being 30 sites where they met our criteria and we did the full sampling protocol. And then we had 108 sites that we looked at. 11 were not accessible, 97 were visited but weren't appropriate for some reason. They didn't meet our criteria. And in total, 127 sites were visited in 31 field days, 25 in Alberta and 6 in BC. And Laurie, who did a lot of this work, had to figure out 125,000 kilometers squared by the convex belt. They did a lot of driving. So looking at the reconnaissance sites that ended up not being appropriate, we can see we covered a range of ecosite types in Alberta and BC, from including boreal highlands and the mixed wood zone and lower and upper foothills zones and different ecosites within them, and then a variety of ecosite types in British Columbia as well. And all of these were found to not be appropriate or not meet our criteria for some reason. So why is this? Why did sites not meet our criteria? So this shows by color why they didn't meet our criteria. There was a number where ended up being less than 70% pine, despite our best efforts to make sure that they were only going to stands that were 70% pine. A very large number ended up being gray, less than 50%. Some were logged when we got there, some had advanced regen more than our criteria, and then some were different combinations of that. Some had a little bit of pest management treatment that we weren't aware of before we got there. Some of the pine was too young, and then there was different combinations of that. But less than 50% gray was one of our our biggest constraints you'll see by the light green dots there. Just a couple pictures of the advanced regen. So we did find a number of sites that had a good amount of advanced regen, most typically spruce, white spruce, or black spruce, or some combination thereof. And those sites weren't a waste, because Phil Como has a FRIA project where he'll be looking at release growth in these types of stands. So we passed off our information to him, so we'll give him a set of stands to use for that study. Looking at attack stage by relative percentage here, so the biggest red dots are where red was dominant, then gray, then green, and then light green is there. And so you can see that there were a lot of stands. There's not a lot of stands where red was dominant, and there's not a lot of stands where gray was the dominant. There's a lot that were all three together. We have 44 of these stands were gray, green, and red combined together. And depending on how much of it was gray, they may or may not have met our criteria to have at least 50% gray. So just a couple pictures of the attack stages here. So here's an example of a site in BC, 70% gray, 30% green. And when I say green here, I mean the trees were green. So these are not necessarily green attack trees. We weren't looking at all these trees to see whether they had been attacked or not. That's part of what Nadir will be following up on. But they were green trees. Example, northwest of Manning, we had a site that's 45% red, 45% green, and 10% gray. One north of Fairview, 90% green and 10% gray. So they ran into a lot of sites that were like this, and to the point where they were sort of in a warped way going to a site and just desperately hoping they'd find a bunch of dead trees, which didn't really seem like what you'd want to be doing normally in a research project. MPB attack year based on our best available data from BC and Alberta government. So we were looking in Alberta mostly at areas that we believe to be attacked in 2006 or 2006, 2007, so the oldest possible really that we could get in Alberta. And then in BC we got into some sites that are a little bit older, even going up to some that were hit in about 2000 or 2002, 2003 here. So we were trying to get the sites as old as possible so that they would be gray and that there would have been some opportunity for lodgepole pine to regenerate in them. These are the full protocol sites, so the sites that we actually met our criteria and we worked, and we have a variety of ecosite types, lower foothills, boreal mixed wood zone, boreal highlands, and even one subalpine site. So we looked at a number of different ecosite types, the dominant one being, we had 11 sites that were lower foothills F1 ecosite type. We looked at cone serotiny when we were there as well, and you can see that there's a lot of variation in the percent of cones that were open, but somewhat disturbingly or unfortunately, the area where we were most successful at finding the sites that had the highest level of gray trees in Alberta were areas that the cones were by and large not open. So we were looking at cones that were on the ground, not when they were on the tree. So we were looking at when branches had fallen down onto the ground, and that's the ones that we expected have the highest probability to actually open. And there was not much cone opening in this area here, which is where we found a number of our sites that were gray. And then in some areas we found relatively higher amounts of cones opening when they hit the ground. So there is some variation in the level of serotiny. That's probably a product both of genetics of the trees and also the environment into which those cones are falling and whether they're getting enough sunlight to warm up and open up. Okay, what do we find for pine seedlings? Not very many. 12 of our 30 sites we found some pine seedlings, 7 of the ones in BC and 5 of the ones in Alberta. All the seedlings were lodgepole pine except 3 sites in the dry mixed wood where they might be jack pine or jack pine hybrids as well. You can see here the numbers, the density is 50 per hectare. Here in some sites in BC we got up to 500 per hectare, 50, 25, 25, 35 per hectare. So very, very low levels of seedlings. And we had a search strategy where we were originally just doing sort of belt transects, searching carefully, and then we took an even more proactive approach where we looked at the microsites that we thought were the highest probability, where we went to the places where there were cones lying around and branches lying around where seeds might have come up. So we're trying to really optimize our chances of finding the seedlings if they were there, and they just really weren't there. What you will notice here is that in Alberta, the site types that tended to have seedlings were the drier ones. So we see here in the mixed wood zones a B1, and then we have here the C1 here, and the D there didn't have any. So it tended to be the drier, poorer pine sites that ended up having the seedlings. So this is where the types of sites that they would typically find. So they have low vegetation, not much herbaceous vegetation, lichen kind of sites, and that's where you would get pine regenerating naturally. The kind of sites where we didn't find seedlings, or only rarely found them, were the richer site types. So here's a D ecosite type and an F ecosite type in the Saddle Hills, and you go in there and you go, really? You know, my enthusiasm for thinking that I'm going to find a live lodgepole pine seedling underneath that is really very low. You know, the herbaceous vegetation in some of these sites had really, my perception is that it had taken off. We don't know what they looked like before, but it was really very lush and tall, and would have been really severe competition for these little seedlings trying to establish. So what did we learn from last summer? First of all is that these pine stands in Alberta either show really gradual mortality post-mountain pine beetle, or only partial mortality post-mountain pine beetle. So we found a lot of these sites where we had gray trees, which had obviously probably been attacked early on and were dead, and that was mixed equally with green trees. And so the question is, what's the fate of that stand? And Nadir is going to follow that up, look at some of those stands and try and understand what's happening. Are the green trees still possibly going to be on their way out, or are they going to live, or are they more susceptible to other diseases or pathogens that might attack them now because they've been weakened? Very, very little natural regeneration post-mountain pine beetle in the time frame that we looked at. We saw more in the BC sites. They were a bit older, so that might possibly be why we found more, and then also the climate is different there, so it might be more amenable to natural regeneration, being a little bit wetter than in Alberta. Nothing anywhere near full stocking in these stands, and most of the sites without seedlings, it seemed pretty clear that it was going to be a while before there'd be really any kind of reasonable chance to get a decent amount of natural regeneration of lodgepole pine in these sites. So it seems like in some way, I mean, we know that mountain pine beetle is a novel disturbance in Alberta. Our forests haven't experienced it a lot in the past. This really slow mortality almost seems like it's even worse for these sites in terms of the possibilities for natural regeneration. The trees die slowly, the resources aren't available, it maybe gives an opportunity for the understory vegetation to take off, and that's going to be presenting a challenge, a competitive challenge for lodgepole pine regeneration. The organic layers are very thick and dry, so the microsites for regeneration are not very good. We know we have a lot of sites without advanced regen, and then if that's combined with high serotinity, then the overall picture for much natural regeneration on these sites seems pretty bleak. So the plan going forward, we're going to continue some more surveys in the coming year. We're going to look at more of these towards the drier, poorer ecosite types, and try and get a better handle on what's really happening in those sites where we do have natural regeneration. And we're also going to look at some lightly treated sites, some types that have had some sanitation, so a really low level of disturbance, and see what that provided in terms of an opportunity for natural regeneration. And then we're going to survey the silviculture sites that we're talking about down here. Nadir's going to look at residual. The original plan was to look at the residual live lodgepole pine and the seedlings, but since there's no seedlings really for him to look at, he's going to concentrate on looking at the live lodgepole pine in these partially killed stands and see if he can predict the future for them. develop operation scale harvesting and site preparation, so that's the study that Derek will talk about next, and we will look at natural regeneration and do some experiments, some sowing experiments to see what could be the possibilities for natural regeneration in managed stands. And then Mike Flanagan has a master's student who's here somewhere, if you want to, back there, Hugh, who will be looking at the fire risk in these sites that are partially harvested. So that's the plan ahead. I'd like to acknowledge the funders. In addition to FRI, there's 2 different FRIA grants, one through Canfor and one direct to us. Alberta Innovates Biosolutions and AESRD have all funded this research.